Hello, everyone. This is Mina from Hoi Technology. Today, my topic is Innovated SRAM, BIST, and BISR solution, which name is START. With the progress of time, science and technology change rapidly, especially for artificial intelligence science. It's known to everyone that artificial intelligence science is being used to analyze large amounts of data and predict the future trends. It needs excellent computing power and many memory devices to store the related information. But only few people may aware of a problem that the more memory is used, the more faulty memory might have. Therefore, Hoi provide an innovative memory test and repair solutions to improve this problem, which name is START. In the later, we will describe more details about START, and besides, we will briefly introduce our company Hoi to let more people get familiar with us. In 2015, AlphaGo became the first computer program which beats the European champion by winning 5-0. Suddenly, all attention is focused on artificial intelligence science. Scientists begin to think about what AI can do more for human beings. Today, 2018, only 3 years, artificial intelligence science is almost everywhere in our life. You can see it in security field, smart home, and Internet of Vehicles. For example, the unlock way of your cell phone might be facial identity or fingerprint recognition. In your home, you may control your home appliance with a smart speaker rather than many remote controllers. And when you go out, you may rely on an autonomous vehicle to help you to do the parallel parking. Based on the description above, it can be inferred that the artificial intelligence science can be applied on almost every industrial field, and its revenue is greatly increased. Please refer to this figure. From 2018 to 2025, its revenue is predicted to be increased by about 15 times. Therefore, many companies have begun to develop their own AI algorithm. Furthermore, to develop ASIC for their own design to maximize its performance, such as Tesla, Amazon, or Apple. Due to the most significant feature of artificial intelligence science is that it can deal with large amounts of data. The artificial intelligence science is being used to deal with database, which is too large for scientists to analyze. The hardware design of ASIC needs much more memory than before. The ratio of embedded memory to logic is greatly increased. However, there is a concern that as the wafer fabrication became more and more complicated, the chance of having faulty memory is much more higher than before. You can see that in 90 to 180 nanometer technology node, it has only 6 kinds of defects. But in 28 nanometer technology node, it has 14 kinds of defects, which needs new test algorithm to detect them. The old algorithm cannot detect those defects, which is created by new semiconductor process. Therefore, for advanced technology, the chip quality has become the most important topic. In order to improve the chip quality, it needs a memory inspection to detect the faulty memory and a repair mechanism to repair it. Therefore, Hoi provides a memory test and repair solution, which name is START. START can generate that circuit area by using a hardware sharing architecture and can improve the array by using the flexible repair mechanism. Most of all, we provide a user-friendly GUI for users to get used to it. In the later, I will describe the START flow and the hardware sharing architecture, and our repair mechanism, and the GUI of START. The START is an electronic design automation tool. It will based on the design files and the configuration data to generate the output RTL files, floating memory, and test benches. The START architecture can be divided into two parts. One is BISR flow, which is used to insert the BIST circuit into user's design. The other one is BII flow, which is used to do integration. Let's check the BISR first. BISR is short for BIST feature list, which is a setting file used to set the related options for START. It can start. It will passing the design files and the BISR files, and the START will start to identify and classify memory in the design, and trace the clock source automatically, and then insert the BIST circuit into user's design. After all these steps, it will generate 5 kinds of files: a pure BIST circuit, and an insert design, which is insert the BIST circuit into user's design, synthesis script, floating memory, and test benches. After finish the BISR flow, here goes the BII flow. The BII is short for BIST integration information, which is also a setting file. The START will integrate the interface of user's design and the interface of BIST circuit together based on the BII file. As what I've mentioned above, the START will generate the BIST circuit for user's design, including a controller, sequencer, test pattern generator, and test redundancy analyzer. The controller is used to choose the testing pattern, and the sequencer is used to execute memory test instruction based on hardware sharing concept and the memory group architecture. The sequencer will send instruction to the test pattern generator, and the test pattern generator will do the S-speed execution and compare the test result to check whether the test result is correct. If the repair is needed and the memory needs repair, it will generate a test redundancy analyzer, which is in charge of control the spare redundancy memory. This architecture could save a lot of gate count compared to the original memory testing circuit. Here I will introduce 2 traditional repair mechanisms, soft repair and hard repair. Soft repair will do the BIST test at the boot-up stage and store the related information in buffer, which is a volatile memory, and it will lose data whenever it is powered off. On the other hand, hardware repair will do the BIST test at the first time being used and store the related memory in eFuse, which is a non-volatile memory, which means it can retain data during the power-off period. However, because it only do the BIST test at the first time being used, it cannot repair lost memory cells, which is broken at the using period. Considering about the weakness of soft repair and hard repair, HOE provide a new repair solution. It can start the repair flow if the START has found any faulty memory and store it. And if the repair is needed, the spare memory will be used for repair. HOE provides an accumulative repair technology. The reason why we call it accumulative is that after repairing, the information will be kept for the next time use. And the next time when user executes the test and repair process, it will check the previous data first, which means each time when START execute the repair flow, it will work based on the previous data. That's why we call it accumulative. After finish the technical feature of the start, let me introduce you our GUI, which is used to set the related options for BIST generation and integration. Here is a simple example for our BFL file. It lists many parameters, such as a Verilog path. You can just type your file path here, or you can click your button and to choose the desired file in your working folder. For some simple settings, such as enable and disable, you can just click this button, and which means enable the auto group function, or just leave it blank, which means disable this function. We provide many BIST algorithms. You can just click BIST and click algorithm. Here list many algorithms. You can just choose one you need by simply clicking it. It can be seen that the operation of our tool is very intuitive and very easy to learn. In addition, we provide a prevention mechanism from setting error. There are some settings cannot be turned off at the same time, such as clock trace and clock switch of memory. If there is a conflict settings, it will show a warning message to remind user from setting error. Furthermore, in order to help user to understand each parameter, it will show the parameter description automatically. For example, when cursor is pointed at the integrator mode, it will automatically show that this option is used to add dedicated test port in top module for BIST. After you finish off the settings, you can just choose Run to start the BIST generation process. Based on what I've mentioned above, it can be inferred that Start has many advantages, such as it costs smaller gate count and a shorter testing time. It provides a user-friendly operating settings, and most of all, we provide high fault coverage with many BIST algorithms and a flexible repair mechanism to improve the ERA. Now, let me introduce you about our company. HOE is founded in 2010 in Hsinchu, Taiwan, Republic of China. Our investments include MEGA, HNVC, National Development Fund, and MSCI Technology from 2016. Nowadays, we have 34 professional memory testing patents in US, Taiwan, and China. Our goal is to provide innovative, cost-effective memory testing and repair solutions. And our tool can be applied on many applications, such as TCOM, IoT device, and a wearable device. To meet different customers' needs, we provide many tool solutions to fulfill different customers' demand. Today, I only introduce about Start. If you are interested in our tool solutions, please feel free to contact us. Our tool can be applied on many different applications, such as artificial intelligence science, TCOM, automotive vehicle, and wireless charger. Therefore, our customer is located in many different countries, such as ASIC Land in Korea, Focotech in Taiwan, Haixin in China, and Sequans in France. For each customer, we all provide excellent support for them. If you are interested in us, please feel free to contact us. We are very pleased to give you more information about us. Thanks for your listening.